Hello, this is a continued video on funding in a project financing and the circular references that arise. In the last video, we discussed how to make a function, and I abrupted it, excuse me, a little bit early because I had a minor problem that I'll show you. If we put true here as the switch, we get the correct amount of, here's the amount we get in the function for capitalized interest over the entire period. This sum of line 100 simply sums the whole line of capitalized interest that's computed from our debt schedule, and there we have it. In this case, there was no funding needs there were no funding needs associated with the interest during construction. Let's put this capitalized interest back to false for a minute. Okay, and when we put the capitalized interest back to false, the whole process still works, and we this time, however, this time we have some capitalized interest. Now here, in this case, it looks like I have a delay in construction, which is just fine. And let's just look at the function for just a minute. The function reads in the debt percentage, the switch for the capitalized interest. I should have called that a switch. The capital expenditure, the construction switch, the working capital, and the interest rate. This time, I added a little thing that says, to make sure it's really a number, and if it's a number, then we can click on the entire row. Just click on the entire row instead of limiting it. And I put the same little test down here, and we have just a little routine that does all the non-circular things first, computes the initial values. We have to set some values to 0, and then we work through exactly the same calculations that are in the model. That's the whole trick for this. And we have a pro rata percent as the capex divided by the total capex, and that's what we'll work on right now. Now, if you, and that's why I set it back to the interest during construction as being paid. So if we would want to change our pro rata percent, and we'd want to take this number divided by the sum of this number, then we get our dreaded blue lines, and that makes it's kind of an intuitive circular reference, because let's see, the interest during construction depends on debt, but the debt is driven by the interest during construction, which is also affecting the pro rata ratio. Now, you could have done it like this. You could have took this one, taken this one, and divided it by the total project cost. And this total project cost down here, it includes all the functions. Well, now we're okay. Now the only thing, oops, we're not okay. Oh, that's because I didn't lock in the cost. Excuse me. Okay, oops, come on. Okay, I'm almost ready to simply stop the video on a damn F4. Nothing. 1, 2, 3, 4. 1, 2, 3, 4. Oops. Come on. Okay. And Shift Control R. Remember the wonderful. Whoops. Shift Control. Okay. I press Shift Function R. Shift Control R, and now we have a little bit of different ratios over time. And if we sum this, we're going to, I don't get exactly that 100%. Oh, that's because now our formula is different. So we have to enter this into the model, and we're going to have a problem that capex here is still greater than 0. It's still, the capex equals 0, and we're going to have to make an adjustment now. Let's work on this. So let's do the easy part. So the easy part, I hope, we'll just have a new function, and the new function, instead of pro rata, we can put funding needs, okay? And funding needs equal, the capex is number. That should be fine. Funding needs equals the capex. And here's something that's crucial. Always include the array, whatever it is, the index, whenever you would have an array. But this time we'll put plus the working capital. I believe that's got an index too, and plus the IDC. But this is the, I suppose we can put plus the, this is the IDC for this period, and we want to subtract the capitalized interest, because that's, and I think we can do it here. And we're just going to have to, this is clearly the circular reference, so we're going to have to go around and around on this. Okay, and the total funding needs, we don't really have to compute it here, because the total funding is equal to the project cost but we're going to subtract off the total amount we had of interest capitalized. Okay, and so we can this time put up pro rata percent instead of being the simply the capital expenditures. This time a pro rata percent could be the funding needs. And we take our funding needs and divide those by the total funding. Now there's one other thing that I did down here, and that's the test. We said, well, what was the debt the last go round, and what was the debt this go round? I suppose you could have done this really with the total IDC. That's really what's in the program, and then you exit the function. So you go around the iteration for maximum of 20 times, and then you stop it when it's this. This was a little bit crude. Maybe we'll put one more decimal here to get a little better. And now let's try it. And of course, what I need to do is to I'm going to stop this video. I don't trust myself, and I'll tell you the result. Okay, I just tested this out. It worked. I had to make two little adjustments, of course, in the file. One of the adjustments was that we needed, in this case, we really made a tiny bit of difference, which is frustrating. The IDC had to be before the funding needs, which makes a lot of sense anyway. And we needed a total project funding right at first. I thought that might be the problem, because if we went to the first iteration and divided by 0, then the whole function doesn't work. So there are a couple of lessons in this. Now we're not quite finished with this. So now we have our funding function. Excuse me, but and I hope you can see that it took a long time for me to do, but it's not really that that difficult. We have one thing to fix, but let's put the capitalized interest back to true, and then I believe it won't work, and it shouldn't, because now we have nothing here in the capitalized interest, but the big problem is we only have our funding ratio doesn't add up to 100%, and we have a difference between what we put in the function and what we computed in the model. That's our big test, and that's what we can do with virtually any of these functions. Now, I think the real problem is simply we have to take this number, and this number includes the IDC, so we need to subtract the capitalized items now. I hope this doesn't create a circular reference. It didn't so far. Shift Control R, and then we're back to our 100%. And did I, just a minute, is the equity IRR down here? Debt IRR, project, there's the equity IRR, 28, very high, unrealistic IRR, and but before that we seem to have a little bit of a damn problem here, and so I'm going to have to stop the video for just a minute. Okay, here was the mistake I made on the last one. Excuse me for that, sorry. And in this case, what I had done is I had put the total funding is the project cost minus the total IDC here, and I put it up here, so the project cost was computed here, and then the IDC, for some reason that thing had to be before the iteration loop after. I can't even explain this right now. So that's our why don't I delete that? And that's our routine so far for the interest during construction. And again, if you want to find out more, there are a whole lot of these videos. I don't know if anybody would watch them all. You'd be nuts. I think it's a lot more better to just take a class, and then the idea of these videos is to be able to really follow up and select which subjects really are the most important ones, and that you can take at www.financeinstitute.com. So that's my advertising.